The speed and power of computers has been doubling every 1 to 2 years since the 1960s and 70s. And now, artificial intelligence combined with that computing power could be poised to solve some of technology's biggest barriers. But scientists now say that humanity is at a critical crossroads, and the path we choose in the next century will shape the course of our civilization for generations to come. Will humanity one day reach the highest level of technological advancement, allowing us to become an interplanetary species with the ability to colonize entire galaxies? Or will our own technology doom us? Stay tuned to find out. In 1964, Soviet scientist Nikolai Kardashev put forward a groundbreaking theory proposing that all civilizations, regardless of the race or culture of their inhabitants, require energy to sustain themselves. As societies grow and develop, their energy needs increase exponentially, driven by factors such as population growth, rising living standards, and technological advancements. To measure the level of energy consumption, Kardashev devised 3 levels of civilizations, but other scientists have since suggested 4 more levels. Each type of civilization is distinguished by their level of energy consumption and technologies they use. Now, let's take a look at each of the 7 types. A Type 0 civilization uses almost all of the natural resources on their planet to obtain energy, launching into space using rockets fueled by chemical energy. That's where we are right now. This is because a Type 1 civilization consumes a minimum of 10 to the 16 watts of energy, and we currently consume about 10 to the 13 watts of energy. This puts us at about 0.73 on the scale. According to American theoretical physicist and futurist Michio Kaku, it's estimated that humanity will be capable of consuming energy on a scale comparable to that of a Type 1 civilization within the next 100 to 300 years. But to cross this line, we have to get through the Great Filter first, a phenomenon that wipes out civilizations long before they can encounter each other. The theory behind the idea that each extraterrestrial civilization ultimately faces some barrier to its own survival came from economist Robin Hanson. This Great Filter can be anything from nuclear warfare, pandemics, artificial intelligence, planet-killing asteroids, or even climate change. If we make it past whatever the Great Filter will be for us, only then will we be able to advance to the next civilization type. Civilization Type 1 is also known as a planetary civilization. When we finally reach this stage of evolution, we will be able to establish control over all energy resources available on Earth. This means that us humans will need to fully utilize all the solar radiation that reaches our planet. The Earth absorbs about 71% of the energy that the Sun radiates, and each hour, 430 quintillion joules of energy from the Sun hit the Earth. The total amount of energy that all humans use in a year is around 410 quintillion joules. That said, if we were able to harness all of this energy at once, we'd be able to power everything with just the sun. Wind, along with hydroelectric energy, would add even more resources for developing technologies. When it comes to harnessing the power of a star, it will be nuclear fusion that creates a huge breakthrough in clean and reliable energy. But the old stuff certainly needs to go first. Our current nuclear power plants run on fuel that undergoes nuclear fission, has a low energy conversion coefficient, leaves behind radioactive waste, and carries a high risk of accidents. Nuclear fusion, on the other hand, will provide a safe and almost unlimited source of clean energy without radioactive waste. By creating engines that can be powered by nuclear fusion, we'll be able to send manned spacecraft to any planet in the solar system. Life on Earth could become more comfortable, climate change could be averted, and it's possible that, in the future, we could build entire cities underwater. Advancements in medicine will ultimately defeat cancer and other incurable diseases, thus significantly elevating the longevity of human life. However, the future holds even greater promise for the next evolutionary level. The Type 2 civilization, also known as stellar civilization, harnesses and consumes a staggering 10 to the 26 watts of energy. Scientists think humanity stands a chance of breaching this limit in about 200 years. Once we get there, it will enable us to tap into the sun's boundless energy reserves. There are multiple ways we can do this, with the most notable being the hypothetical Dyson sphere, a colossal megastructure with a surface area millions of times larger than Earth's, capable of capturing and transmitting the star's entire energy output. Alternatively, a star can be encompassed by a cluster of satellites and space habitats. This method of energy harvesting is sometimes referred to as a Dyson swarm. The The swarm would consist of a large number of individual solar collectors or panels, which could be positioned at different distances and orientations around the star to maximize energy capture. The energy collected by the swarm could then be transmitted wirelessly to a central location for storage or use by the civilization. As humanity ushers in the age of anti-gravity engines, it will unlock new opportunities for extended space travel and the colonization of the solar system. With advancements in medical technology, astronauts will no longer have to worry about the toll that extended space missions have on their health as tissue regeneration and significantly prolonged life expectancy become a reality. However, as our civilization continues to grow and evolve, it's only a matter of time before the limits of the solar system become constraining, leading us to explore further and push the boundaries of our technology. According to Kardashev's calculations, reaching a Type 3 or galactic civilization may take up to 5,800 years. At this level, we will have harnessed the energy from stars throughout the galaxy, and even collected photons from the accretion disks of black holes. With an astonishing 10 to the 36 watts of energy at our disposal, we'll potentially have the power to travel almost instantaneously across the Milky Way using the mysterious phenomena of wormholes. To further expand our horizons, we'll create advanced races of robots and cyborgs and explore new frontiers beyond our wildest imagination. We'll also probably come closer to the concept of immortality as the human lifespan increases to maximum potential. While this level of development may represent the upper limit of any civilization, some scholars have gone beyond Kardashev's theory and propose models for civilizations of types 4 to 7. A Type 4 civilization would achieve the ultimate breakthrough in our understanding of the universe, harnessing its incomprehensible energy potential of 10 to the 46 watts. Their mastery over the power of supernovae, which explode every 50 years in a galaxy like the Milky Way, will grant them access to vast amounts of energy. And with the addition of dark energy, they will unlock the key to traversing the distant corners of the cosmos, possibly even settling within supermassive black holes. Yet this is merely the beginning of humanity's awe-inspiring journey. As humans of the future delve deeper into the mysteries of physics and energy, they will be able to manipulate entire galaxies, extinguish stars, and form entire new planetary systems. There are hypotheses such as a civilization will achieve the ultimate feat of immortality by transferring their consciousness into digital realms. With such immersive power at their disposal, these beings will rewrite the laws of nature as we know them. But as they push the limits of scientific knowledge, they will also discover that the universe is far more vast and complex than they ever imagined. Perhaps they'll even discover there's a multiverse of universes out there, if multiverses turn out to be their new reality. Civilization of Type 5 will conquer these worlds, harnessing an almost inexhaustible source of energy along their journey. And hypothetical white holes, which are considered the opposite side of black holes, could be the key to achieving this. Meanwhile, science will actively delve into the study of higher dimensions, unlocking secrets and possibilities that were once thought to be fiction. According to scientific theories, a Type 6 civilization would become multidimensional. If humans were to enter the fourth dimension, which is a hypothetical spatial dimension beyond the 3 dimensions of length, width, and height, our physical bodies wouldn't be able to exist or function in this realm. Scientists think that the physical laws and properties of objects would behave differently in the fourth dimension, making it incompatible with our 3-dimensional bodies. But for our descendants, who have risen to Type 6 civilization, this may not be a problem. Theoretically, they could learn to preserve their consciousness as pure energy that can be transferred from one dimension to another. The only obstacle could be energy resources needed to make such a transition. But maybe a Type 6 civilization will be able to extract energy from white holes across multiverses. Although purely hypothetical, whoever inhabits this new reality would move beyond the speed of light, travel back and forth in time, and overcome cause and effect limitations. After hearing all this, you might think there's no further level to advance to. But there may be another tier, the utmost peak of civilization's progression. A Type 7 civilization would consist of the creators of all laws of nature, matter, energy, space, time, and dimensions. We cannot imagine what life in a civilization of the 7th type would look like, or if such a civilization can even hypothetically exist. In this unfathomable universe, completely different physical laws would reign. Even if we were to gain access to them, we would never understand them. In theory, it would take us 10 duodecillion years to become a civilization of this type. Another idea is that we will never reach the 7th level, because it's not a community of beings, but rather existence itself. We wouldn't even notice if such a civilization existed in the first place. Contemplating the possibility of extraterrestrial intelligence is a captivating subject. However, the search for evidence of such advanced civilizations is quite a challenge. Looking for civilizations in the lower levels of the Kardashev Scale would be a more realistic pursuit. The theory of different types of civilizations provides clues for the search, particularly on exoplanets with conditions suitable for life. According to NASA, there are potentially 300 million such worlds in our galaxy, although we've only studied about 55 of them so far. Advanced telescopes, like the James Webb Space Telescope, are not just looking for signs of biological life, but also signs of technological activity. Astronomers believe that with the modern equipment we have today, they would have already detected signs of a Type 1 civilization, if it existed in the regions of space we've already studied. In this case, extraterrestrials would be traveling through space at speeds that would make their ships noticeable. The Type 2 civilization is also unlikely to remain completely invisible to us. In order to gather energy, it would need to surround stars with Dyson spheres. If a Dyson sphere were constructed at the same distance from the Sun as the Earth, and if it were stable, it would enclose a space of approximately 600 million times the surface area of our planet. In other words, the interior of the Dyson sphere would be vastly larger than the surface area of the Earth. According to Dr. Robert L. Forward, such a megastructure with a radius of 1 astronomical unit would require approximately 10 to the 27 kilograms of material, which is roughly equivalent to the mass of Saturn. However, this estimate assumes a solid shell and may not take into account the technological challenges of building such a structure. It would take a lot of building materials and energy to make stars go dark by encompassing them with Dyson spheres. Nothing like this has been detected in the Milky Way yet. However, there were a few times when scientists thought they had found something like a Dyson sphere. When the SETI Institute detected a signal coming from the star HD 164595, 92 light-years from Earth, astrophysicists hypothesized that only a Type 2 civilization beacon could send such a powerful signal, but it turned out to be just a military satellite orbiting Earth. And in 2008, astronomers detected an exoplanet orbiting a super-bright orange dwarf star and dubbed it Fomalhaut b. At first glance, the planet appeared as a bright and cold point of light that quickly moved across the sky. However, in 2014, the planet had vanished, leaving scientists to ponder the reason behind its disappearance. Some suggested that the planet's orbit may have become unstable, causing it to drift away from its parent star. Others proposed that Fomalhaut b had migrated to orbit a different, larger, and brighter star elsewhere in the galaxy. It wasn't until later that researchers discovered that the celestial body was not actually a planet, but rather an enormous cloud of frozen debris. This debris is thought to have formed from a massive and violent collision between two icy asteroids, an extremely rare phenomenon. Although we may never know for certain what happened to Fomalhaut b, it's possible that a Type 2 civilization was in need of building materials for their next megastructure, such as a Dyson sphere, given the uncertainty surrounding the disappearance of stars. It begs the question of how we would even begin to trace the activity of a Type 3 civilization. Civilizations of Type 3 are either very rare or simply don't exist in our local universe. Astronomers have searched for them using the infrared telescope WISE, expecting to detect large amounts of infrared radiation that such highly advanced civilizations would emit. So far, no signs of such activity have been found, but astronomers remain hopeful. It's hypothesized that a Type 3 civilization may be hiding in giant cosmic voids, the origin of which is not yet fully understood. One particular area of interest is the Boötes void, which is almost entirely devoid of stars and galaxies, and has a diameter of 330 million light-years, making up approximately 0.27% of the diameter of the observable universe. According to scientific speculation, the empty space may be attributed to the various kinds of activities by an advanced Type 3 civilization. It's possible that some extraterrestrials have been obscuring entire galaxies one by one, covering their stars with Dyson spheres or moving them to the desired location. Scientists hope that Earth's technological advancements will allow them to test this hypothesis in the near future. Do you think we'll ever find intelligent life out there? And if we do, should we ever try to get in contact? Sound off in the comments and stay tuned here to know about the most mind-boggling cosmic discoveries. Thanks for watching.